Hi, my name is Joe DeRossi, and today I'm going to be talking to you about Newton's laws of motion. Newton's laws of motion are three basic laws that form the basis for classical mechanics. They describe the relationship between forces acting on a body and its motion due to these forces. Newton's first law states that an object at rest stays at rest, and an object at motion does not change its motion unless acted on by a net force. For example, this box is at rest and will stay at rest until you do something to it. A box moving at constant speed will stay moving this way until you do something to it. Newton's second law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to the mass of the object. Newton's law states that if object A exerts a force on object B, then object B exerts an equal force on object A in the opposite direction. It is a Newton's third law pair if the forces have identical magnitudes but in opposite directions. An example of this would be me putting my finger on this pencil. However hard I put my pencil on, the pencil will return the force of the equal magnitude back onto my finger. You can see this by the little indent it leaves in my finger. The problem I will be working out is number 1 from the book, chapter 5. It deals with Newton's second law, and it states that a woman that weighs 120 pounds determine her weight in newtons and determine her mass in kilograms. For this problem, we kind of have to work backwards because we want to find out what her mass in kilograms is first. So we take the 125 pounds divided by 2 pounds, or 2.2 pounds, my bad. And we get 54.5 kilograms. Next, we know that the formula to get acceleration or force equals mass times acceleration. We know that the acceleration on Earth is 9.8 meters over second squared towards the Earth. And we know that her mass is 54.5 kilograms. We calculate that out. I don't have my calculator, so I'll just do it here. And we get 534.1 newtons. In conclusion, it is important that we study Newton's laws because of the everyday applications that they hold. For example, we all feel Newton's first law every day when we drive a car. When the car takes off, we tend to go backwards because we want to stay at rest, but the car is going in motion. And when the car comes to a stop, we tend to go forward because we want to stay in motion since we are already in motion. Newton's second law is important because it lets us calculate the force of everyday actions. By taking the mass and acceleration of an object, we're able to find the force, which is important in a lot of different fields. Newton's third law is important because it describes everyday things like how I'm able to walk around. I exert a force on the floor and the force exerts an equal force on me.